That's quite a machine, the mud pump. Without it, you wouldn't do much drilling. With the proper care and maintenance, your pump will run for a long time before it requires frequent adjustments or major overhaul. That's important, proper care and maintenance. This adds service life to the equipment, reduces drilling costs, and makes your job a little easier. Ideally, the pistons on your mud pump should be centered in the liners and move back and forth without deviating from side to side or top to bottom. Any deviation is often caused by misalignment. You should understand that your crosshead, pony rod, and piston rod are supposed to form a straight line. The crosshead guides, diaphragms, or stuffing box, and liner also have to be in line. If so, all the parts will work together smoothly. If even one item is not in line, you have misalignment, and something's going to bind, causing rapid wear and failure. Running a misaligned pump will cause failure of the pistons, the piston rods, diaphragms, and in duplex pumps, the stuffing box bushing, and even the stuffing boxes and glands. If you don't detect misalignment, you can waste a lot of time continually replacing worn pump parts. Long periods of misaligned operation can cause failure of the crosshead guides, and eventually the crossheads. Now this is pretty serious. All failures are costly, and failures that cause downtime should especially be avoided. What causes misalignment? Generally, it's wear. Wear is normal anytime you have moving parts, but accelerated wear can mean trouble. You can prevent rapid wear by ensuring lubrication of the moving parts. That is, making sure you have clean lubricant and that it gets to the parts that need it. You can find out more about your pump's lubrication in the Power End program of this series. Other causes of misalignment can be an improperly installed extension rod clamp or a pony rod that isn't properly mated to the face of the crosshead. If the fluid end or fluid end segments have been removed from the pump and haven't been carefully reinstalled, this can also cause misalignment.
This is retake showing the standoff of the fluid end from the power end facing plate. This fluid end has not been properly tightened and will have to be corrected before the pump is released for service.
And normal wear of the lower crosshead guide will eventually result in misalignment. How can you tell if you have misalignment? Here's some things that'll clue you in. If the diaphragm wipers or seals leak and have to be frequently replaced, look for misalignment. If the pony rods are scored and have long grooves in them, or if they wear more on one side than another, look for misalignment. This would also be true of the piston rods in the duplex pumps. If pistons are failing frequently, and inspection of these indicates they're being forced to one side of the liner during operations, check for misalignment. If the liners wear irregularly, or if they have long grooves in them, caused by the steel piston body making contact with the bore surface, check for misalignment. If the piston rods or extension rods break, or if the rod packing in duplex pumps wears more on one side than on the other, look for misalignment. Keep in mind, though, that the most frequent cause of rod breakage is improper tightening of the piston rod nut, or improper makeup of the piston rod to the extension rod, or of the extension rod to the pony rod. If the pump is running in reverse rotation, it'll always have some degree of misalignment because in this direction of rotation, the crossheads are being forced by the connecting rod against the upper guides at the beginning of the power stroke, and they fall to the lower guides at the end of each stroke. Naturally, you should avoid reverse rotation of your pump. Proper rotation means the top of the crankshaft should be moving toward the fluid end. You should know that misalignment isn't the only thing that can cause trouble and the failures we've mentioned, but when these conditions occur, misalignment is one thing you should look for. Okay, we've got symptoms indicating misalignment of our pump. How do we know it's misalignment for sure, and how do we determine where the misalignment is? The first procedure is to isolate the pump from all power sources. Close off the suction and discharge lines, de-energize lubricating pumps, flushing pumps, controls, and charging pumps, And be certain the unit can't be started remotely, such as from the driller's console. With the crosshead door removed, use a feeler gauge to see if the flange on the pony rod is in full contact with the face of the crosshead. There shouldn't be any gap between the flange and the crosshead. If there is a gap, remove the clamp between the pony rod and the piston rod extension. Remove the locking wire from the cap screws holding the pony rod to the crosshead, and tighten the cap screws. Look in the maintenance manual for the right torque value when tightening these cap screws. If tightening the cap screws doesn't close the gap, remove the diaphragm housing. Then remove the pony rod and check for metal burrs or foreign material on the mating surfaces of the rod and the crosshead. Use a file or emery cloth to get these areas smooth. When you get the pony rod in proper position, the cap screws fully torqued and the locking wire installed, check to see if the rod is in the center of the diaphragm opening. This should be done with the crosshead at the beginning of the pump stroke, midway of a stroke, and at the end of a stroke. There are several ways to check this. In this instance, an adjustable parallel is inserted between the rod and the bore of the diaphragm support. An outside micrometer is used to measure the exact clearances between rod and diaphragm bore. On a pump that's been operating for some time, you'll often find the extension rod is closer to the bottom of the diaphragm opening than it is to the top of the opening. This is normal because the crosshead, as it travels back and forth in the crosshead guides, will cause wear on the bottom of the crosshead, or in the lower guide. As this happens, the crosshead gets lower, and the extension rod, of course, becomes lower in the diaphragm opening. Usually to correct misalignment due to crosshead wear, it's a simple matter of inserting metal shims under the lower crosshead guide to raise the crosshead back to the center position. To determine how much shim you need, measure the rod clearance in the diaphragm support. Subtract the lower clearance from the upper clearance, and divide your answer in half. That's how much shim you need. Remember, you can improvise when checking this clearance. Use a piece of wood or metal and a feeler gauge, or inside calipers, if you don't have a telescopic gauge and outside micrometer. Guys have even done it using long-nose pliers and C-clamps. Remember to take these measurements with the crosshead at the middle and ends of its stroke. If you get different figures, you'll have to shim the back of the guide differently than the front. If the middle crosshead guide needs shimming, do it before you shim the outer crosshead guides. This clamp holds both the outer and center guides in place. You'll have to remove it to slide a shim under the center guide. Okay, say the rod is 24 thousandths of an inch closer to the bottom of the diaphragm opening than it is to the top of the opening. You need to insert 12 thousandths of an inch of shims under the crosshead guide. Always insert the same thickness of shims at each end of the guide, unless for some reason there's more wear on one end of the guide than there is at the other. In such a case, inform your equipment engineer of this condition. It's important that you install the shims in exactly the right place. We remove the crosshead and guide here to show you the supports where the shims go. One near the gear end, one near the fluid end. To install a shim, slide the crosshead to one end of its stroke using the jack shaft to rotate the pump. We'll work on the end of the guide opposite the crosshead.
Good enough.
Remove the outside clamp that holds the lower crosshead guide, and loosen the inside clamp. Use a pry bar to lift the end of the guide. Line up the metal shim at the support, and slide the shim between the crosshead guide and its support. Slide it all the way under the guide and feel to make sure it lines up on the support. Don't leave some of it sticking out. You have to raise the guide evenly across its entire width. Be sure the shim is directly on top of the guide support in the power frame. Now reinstall the clamp and tighten the cap screws. Be careful with the inside clamp. You don't want to knock the center crosshead guide out of alignment. Now, slide the crosshead to the other end of the guide. Loosen the opposite clamps and install this shim the same way. Retighten the clamps and measure the rod clearance again at the diaphragm opening. Make sure you've corrected the misalignment here. If the cap screws haven't been properly torqued, the guide may have been forced to one side or the other, or it may be higher on one end than it is on the other. When the cap screws are properly adjusted and the rod is centered in the diaphragm opening with the crosshead forward, midway, and at the rear of the guide, install the locking wire in the heads of the cap screws and the sides of the clamps. Now use a long feeler gauge to check the clearance between the top of the crosshead and the inside of the upper guide. This clearance should be between 15 and 25 thousandths of an inch. The feeler gauge has to be long enough to extend completely across the top of the crosshead to be sure there are no tight spots where the clearance is less than 15 thousandths. If centering the rod has caused tight spots in the upper crosshead clearance, you've got a problem, so check with your maintenance engineer or tool pusher. If the clearance is more than 25 thousandths of an inch, insert shims on the top of the guide to bring it within tolerance. This pump had too much clearance, so we need to install shims above the upper guide. Do it like you did on the lower guide. Be certain to retighten the cap screws, check the clearance again, then lock them in place. The clamp area between the pony rod and the piston rod extension on a triplex pump is a potential trouble area. If the clamp isn't properly installed, you can break a rod or cause other misalignment problems. So when you're installing the clamps, inspect the ends of the rods for burrs, caked mud, or anything that might interfere with the alignment and clamping. Use a file if you need to smooth the area. Install the clamp good and tight. It's obvious there are several things that should indicate to you a potential alignment problem, and there are several places to check when looking for the cause of misalignment. It's a lot to remember, so let's test your knowledge and troubleshooting skill. So what if my mud pump is misaligned? What will it hurt? Misalignment will cause premature failure of nearly all fluid end parts, pistons, liners, rods, diaphragms, stuffing box bushings, and it can damage the crossheads. What causes misalignment? Wear of the crosshead and lower crosshead guide, improper clamp installation, a poorly installed pony rod, improper fluid end installation. These are the most likely misalignment problems. How can I tell if my pump is out of alignment? If the front end of your car is out of alignment, you'll see uneven wear patterns on the tires. If your pump is misaligned, you might find such uneven wear patterns on fluid end parts, scores or grooves in the pony rod, or in the piston rod of a duplex pump, leaking rod wipers or frequent piston or liner failure, especially if all the wear is on one side. Other indications of possible misalignment are braking rods and uneven rod packing wear in duplex pumps. If your pump demonstrates some of these symptoms, you should check what areas. Check the mate of the pony rod to the crosshead. It should be tight with no gaps. Check the clearance of the pony rod in the diaphragm support opening. The rod should be centered. If it isn't, install shims beneath the crosshead guide to center the rod. Anytime you do this, be sure to check the clearance of the crosshead at the upper guide. Check the mating surfaces of the pony rod and piston rod extension and the clamp that holds them together. Look for burrs or foreign material that could prevent the rods from clamping together in line. If you had trouble remembering these things, watch this program again.